All right, let's handle this next one. As always, everybody, first things first, we read that question. Question sentence says, how many crates fit on the shelf? Sounds good. So everybody, so we don't get burned twice in the same session. When we read that question, and we're saying, hey, how many of these things fit on this other thing? Can you tell me what operation might be lingering in your head, everybody? What might be lingering in your head when you're saying, hey, how many of these things fit onto this other thing? Again, the primary key word here being the word fit. Yeah, that's going to be division. That's going to be division. Because remember, let's go ahead and say I have, let's say I have $20. Again, that's as high as my bank account has been all week long. And let's say we're trying to see how many times you can fit $5 into $20. That's division. 20 divided by 5 is 4. So you can fit $5 4 times into 20. Again, division. Fitting one value into another value, figuring out how many times it can fit is division. So knowing that, what are we dividing? We're going to be dividing, well, whatever value represents the area of the shelf, we're going to divide that by the area of the crate. Because if we divide the space that the shelf takes up by the space that each crate takes up, we will find out how many crates will fit onto the shelf. So we have to be consistent there, but let's go ahead and see what values we have. The shelf, what is that going to be? It's rectangular. It's a rectangular storage shelf, and its surface is 12 feet by 8 feet. So if I wanted the area of the shelf, my party people, if I wanted the area of the shelf, that's going to be 12 feet times 8 feet, because that is going to be the area of a rectangle, and that'll be 96 square feet. So we have that going on as 96 square feet. And everybody help me out. What was the area given to us for the area of each crate? Yeah, that's going to be 4 square feet. So now that we have both of these values, we can now proceed to divide, and we can have ourselves a good day. So let's do some long division. 4 dividing into 96. 4 goes into 9. That'll be twice. Subtract 8 because 2 times 4 is 8. And then from there, drop that 6. And we will divide 4 going into 16. That will be 4. So with that said, boom, there we go. We have 24 crates that can fit on this storage shelf. And the correct answer here, my party people, is answer choice B. Next problem here. First things first, we're going to read that question. And it says, how many minutes will it have run in total? All right, sounds good. So we want to know the total runtime here in minutes. And to assess the information that we have, it says, well, a machine operates 10 hours per day for 3 days. Sounds good. How many minutes is that? So we're not doing 24 hours times 3, everybody. We're not doing that. Notice that it says that the machine operates for 10 hours a day. Not all 24 hours in a day, but only 10. So on day 1, 10 hours. Day 2, 10 hours. Day 3, 10 hours. Everybody, before we can get to how many total minutes, how many total hours is that? Yeah, 3 groups of 10, that's going to be 30 hours. We have 30 total hours. And so now that we get from that understanding to where we are, now we notice that, look, we want total minutes. We want minutes. That's what our choices say. So we have one more task, and that's converting between hours to minutes. Remember, 1 hour equals 60 minutes. So what we'll do is we will understand that we're going to the unit with the 1. So we're going from the unit with the 1 to the unit with multiple numbers. So we're going to be multiplying. And so because of that, right here, multiply by 60. 30 times 60. All we got to focus on is the 3 times the 6, because that's going to be 18. Then we tack on these 2 zeros. Boom. And we have 1800 minutes. And there we are, my party people. That is answer choice C as the correct answer. And here we go. Let's get to this next practice problem here. We are checking this out, and we have another binomial times a binomial where we have 5a minus 2b multiplied by negative a plus 3b. So we'll take this, again, one step at a time. Here, we'll make sure that the 5a multiplies with the negative a. So 5a multiplied by negative a. Then we'll make sure that the 5a also multiplies with the positive 3b. So that'll be plus 5a multiplied by 3b. Then from here, we'll continue with the negative 2b multiplied with the negative a. So minus 2b multiplied by negative a. And then from there, clearly need to go ahead and give myself a little more room, so I'll move it over to the left. And then lastly, we see that we have ourselves negative 2b multiplied with positive 3b. So minus 2b multiplied by 3b. Once we are certain that we have the right combinations written, again, just making sure that everything from one parentheses multiplies with everything from the other, we're all good. Now it's just a matter of cleaning it up with the multiplication, combining like terms if necessary, and then finalizing our problem. So here we go. We have 5a multiplied by negative a, beginning with the signs, that's going to be a negative. Then we have 5 multiplied by a 1. It is there. The 1 is there, even though you don't see it. It is always going to be in front if no other coefficient is shown. So 5 times 1, that's going to be 5. Then lastly, we have a times a, and that's going to be a squared, because again, anything times itself is that value squared. That's number 1. Let's go to number 2. Number 2 here, we have a positive times a positive, so that's going to be plus. 5 times 3 is 15. And then we have a times b, and that's going to be written just plainly so as ab. Next up, third round, we are taking a look at a negative times a negative. Negative times a negative is going to yield a positive result. And then we have 2 multiplied by 1, so that'll just be 2. And then b times a. Everybody, we can just write that as a times b. Again, b times a is the same as a times b. The only reason I swap them out is to show them in alphabetical order, because that's just the better way to write things down. It's just more natural, and it's easier to spot those like terms. So with that, let's go ahead and finish things up with the last one here. We'll have a negative multiplied by a positive. A negative times a positive, that's going to be a negative. And then from there, we have 2 multiplied by 3, which is going to be 6. And then we have b times b, and that's going to end up being b squared. For the same reason that x times x is x squared, a times a is a squared, b times b is b squared. And there we go. Now it's just a matter of cleaning up any common terms that we can combine, and that's it. And those common terms are right here. Positive 15ab, positive 2ab. Everybody, 15 plus 2, that's going to give us what? Yeah, that's going to give us 17ab. So the final answer here is going to be negative 5a squared plus 17ab minus 6b squared. And there it is, my party people. There is our final answer. Boom. Correct answer here in frame is going to be answer choice C.